Long before any handprint appeared on a cave wall, before any known name could be attached to the people moving through these islands, a small group of hominins reached a shore they should not have been able to reach on foot. The land before them was Sulawesi, a vast, strangely shaped island rising from the tropical seas between continental Asia and the ancient world of Australia and New Guinea. More than 1 million years ago, someone stood here, selected stone, struck it with control, and left behind the clearest surviving proof that the island had been entered by tool-making humans or human relatives. Yet between Sulawesi and the nearest continental landmass lay water that no falling sea level could entirely remove. This was not the last dry mile of a migration across an exposed plain. It was a crossing. The tools remain, the travellers do not. To understand why that matters, the familiar map of Southeast Asia must be allowed to dissolve. During the coldest phases of the Pleistocene, enormous volumes of water became locked inside continental ice sheets. Sea level fell, sometimes by roughly 120 meters, and coastlines moved outward across the shallow Sunda shelf. Sumatra, Java, Borneo, and the Malay Peninsula became joined within a broad continental region known as Sunda. Animals and hominins could move through landscapes that are now submerged beneath warm seas. Rivers crossed plains where shipping lanes run today. Forests extended across vanished lowlands. Many journeys that appear maritime on a modern map were once overland journeys, complicated perhaps by rivers and wetlands, but not by open ocean. Sulawesi, however, remained outside that connected world. West of the island, the Makassar Strait cuts through the region like a geological refusal. Its waters overlie a deep marine channel, descending in places to around 2,000 meters. Lowering the sea by 120 meters changes coastlines, enlarges islands, and narrows gaps. But it does not drain a trench of that scale. Even at low sea level, Sulawesi remained separated from Borneo by an estimated distance of about 50 kilometers. The precise width varied with coastlines, currents, tectonic history, and the route imagined. But the decisive fact does not change. There was no continuous bridge of exposed ground. Whoever arrived could not simply follow grazing animals eastward until the forest resumed. At some point, earth ended and moving water began. This distinction separates Sulawesi from many famous Ice Age migrations. Elsewhere, dramatic changes in sea level transformed islands into peninsulas and straits into grassland corridors. Here, the ocean narrowed but endured. Any reconstruction must begin with that endurance, because removing it removes the central problem. The first inhabitants did not merely arrive early. They crossed a boundary that archaeologists once associated far more readily with later cognitively modern humans. Their presence does not prove sophisticated seafaring, but it forces the history of water crossings deeper into the human past. Before we go deeper, take a moment to like the video and subscribe. If this is the kind of history and mystery you enjoy, the mystery here is not based on an exotic legend or a lost map. It begins with geography, and geography is unusually stubborn. Sulawesi belongs to Wallacea, the archipelago of oceanic islands lying between Sunda to the west and Sahul, the Pleistocene landmass of Australia and New Guinea, to the east. This region is named for the naturalist Alfred Russel Wallace, who recognized that neighboring islands could contain sharply different animal worlds. Across what became known as Wallace's Line, familiar Asian mammals diminished or disappeared, while other evolutionary histories took over. The boundary was never a wall, but it was a filter. especially for creatures unable to fly or swim long distances. Sulawesi is the largest landmass within Wallacea, large enough to contain mountains, interior valleys, lakes, rivers, forests, dry zones, and multiple ecological regions. Its 4 great peninsulas extend outward like arms, while deep gulfs divide them. It is not a small speck accidentally brushed by a passing shoreline. Once reached, it could support populations for long periods. Reaching it was the difficult part. Its living and fossil animals reveal that the barrier was crossed on rare occasions by non-flying species. Pigs, bovids, primates, civets, and other lineages somehow entered the island over immense spans of time, often evolving there in isolation. Such dispersals are sometimes called sweepstakes events, because success may depend on an improbable combination of storm, current, floating vegetation, survival, and landfall. The island's highly endemic fauna records both the power of the sea barrier and the fact that barriers are not always absolute. That animal history offers a warning against easy conclusions. A creature can cross water without understanding navigation. Floods can tear vegetation from a riverbank. Storms can drive floating debris beyond sight of land. Currents can carry living passengers toward a coast they never intended to visit. Yet hominins are not passive seeds, and a successful human presence raises problems beyond the survival of one accidental traveller. Stone tools imply hands capable of controlled action, learned behaviour, and some form of cultural transmission. They do not prove boats, planned voyaging, or knowledge of distant shores. They prove only that toolmakers were present after the crossing had somehow occurred. Scholars still debate whether the first arrivals drifted helplessly, used simple natural floats, assembled some form of rudimentary craft, or combined intention with circumstances that cannot be reconstructed. The sea itself has preserved no answer. Wood decays, fibre disappears. A raft simple enough to belong to the early Pleistocene would be almost unimaginably unlikely to survive. Coastal camps may now lie underwater, buried beneath sediment or destroyed by changing shorelines. Even the departure point is unknown. Borneo seems geographically plausible, and later modelling makes it an important candidate. But a plausible route is not a witnessed route. Northern approaches through island chains, southern alternatives, and repeated arrivals remain open to investigation. Currents shift seasonally. Winds change. Volcanic islands appear differently from sea level than from a modern map. On a clear day, cloud formations above unseen land might offer a clue. In haze or storm, the world beyond the horizon would vanish completely. What survives in the record therefore creates an asymmetry. The arrival is certain enough to be taken seriously, while almost every human detail of the arrival remains absent. No vessel has been found. No paddle, cord, landing site, footprint, or skeleton accompanies the earliest evidence. There is no face for the traveller and no agreed species name. There is only the stubborn presence of worked stone on an island that could not be reached by walking. More than 1,000,000 years later, this contradiction still stands at the edge of the Makassar Strait. The water was real, the distance was real, and somehow, despite both, the crossing happened. The discovery at Calio does more than add another old site to a crowded archaeological map. It tears open a gap in Sulawesi's human story and pushes the island's known occupation backward by almost an entire 1,000,000 years. Before Calio, the oldest secure evidence of hominins on Sulawesi came from Talepu, where stone artifacts were dated to at least about 194,000 years ago. That was already remarkable. It placed unknown toolmakers on an oceanic island long before Homo sapiens is known to have reached the region. Yet Calio changes the scale of the problem. Its artifacts are at least 1.04 million years old, and the geological evidence allows the layer to be as old as roughly 1.48 million years. Between Talepu and Calio lies a span of about 850,000 years, longer than the entire recorded history of our species by many measures, and almost empty of direct evidence. The site sits in the Walanai Depression of South Sulawesi, a long tectonic basin shaped by rivers, sediment, uplift, and erosion. Today, the landscape can appear ordinary cultivated ground, exposed rock, low vegetation, and fields worked by people whose lives seem very far removed from the early Pleistocene. Beneath that modern surface, however, ancient river deposits preserve a different world. Sandstone beds, gravels, muds, and fossil-bearing sediments accumulated as waterways shifted across the basin. The artifacts did not come from a museum drawer without context, or from a loose stone picked up along a road. They were recovered from sedimentary layers that could be studied in relation to the geology around them. That context is crucial, because an ancient-looking stone on the surface can move, erode from somewhere else, or be impossible to date reliably. At Calio, the relationship between artifact and deposit gives the discovery its force. Excavations took place during field seasons in 2019 and again from 2021 to 2022. The work was methodical rather than spectacular. There was no buried chamber, no skeleton laid out in complete form, no single object that announced its significance at first glance. Instead, the evidence emerged as a small assemblage of stone artifacts within an ancient fluvial setting. Their importance came from the accumulation of details where they were found, how the sediment had formed, what kinds of fossils occurred nearby, and whether the stones showed patterns of fracture consistent with deliberate napping. Archaeology often advances in this quiet way. A few pieces of stone, carefully documented, can overturn a timeline that had stood for years. Even the location of the finds matters. A river corridor could have supplied water, edible resources, animal traffic, and cobbles suitable for napping. Yet the excavated window is narrow, so scholars still debate whether Calio records a brief visit, repeated activity, or part of a wider occupation. The number of artifacts is strikingly small. 7 pieces form the central assemblage, most of them sharp flakes of siliceous stone. 7 is not a settlement. It is not a workshop floor crowded with discarded cores. It is not enough to reconstruct a complete technological tradition. Yet quantity alone does not determine significance. Each flake carries traces of impact, fracture, platform preparation, direction, and removal. Several pieces indicate controlled percussion with a hard hammerstone. Some suggest that the napper rotated a core to remove flakes from different directions. One artifact has been identified as a Komboa-type flake, produced when a flake is struck from the ventral surface of an earlier flake. Such a piece is not evidence of advanced design in the modern sense, but it does imply a sequence of actions and an understanding, learned through experience, of how stone breaks. That does not mean the Calio toolmakers were making elaborate hand axes, projectile points, or specialized hunting weapons. Nothing of the kind has been demonstrated. Their technology appears simple, flexible, and based on obtaining usable sharp edges. A flake can cut hide, meat, plant fiber, wood, or other materials, but the specific activities performed at Calio remain unknown. No cut-marked animal bone has yet tied the tools directly to butchery. No wooden object survives with shaping marks. The evidence remains incomplete, and the safest conclusion is also the most powerful one: a hominin deliberately struck stone at this place more than 1 million years ago. The dating rests not on the appearance of the tools, but on the age of the deposits and fossils associated with them. Researchers combined paleomagnetic analysis with uranium series and electron spin resonance dating of a fossil tooth from Selabocorus, an extinct pig native to Sulawesi. Paleomagnetism examines the orientation of magnetic minerals preserved in sediment, which can record known reversals in Earth's magnetic field. The fossil dating methods estimate the time that has passed through changes in uranium uptake and trapped electrons within dental tissue. Each technique carries assumptions and uncertainties, but together they provide a stronger framework than any single measurement alone. The modelled mean age of the fossil sample was about 1.226 million years, with an uncertainty of roughly 220,000 years. That range is why careful wording matters. The site should not be described simply as 1.5 million years old, as though the upper boundary were a fixed date. The defensible statement is that the artifact-bearing layer is at least 1.04 million years old, and may be as old as approximately 1.48 million years. This still makes Calio one of the earliest known records of hominins in Wallacea. It places Sulawesi broadly alongside Flores, where toolmakers were present by about 1.02 million years ago, and possibly earlier than the currently known early record from Luzon. The comparison changes how the region must be imagined. These islands were not entered once by a uniquely adventurous late population. Different hominin groups, at different times, reached multiple oceanic islands across Southeast Asia. The events may have been rare, separated by thousands of years, and driven by very different circumstances. Calio does not reveal whether its inhabitants were related to the toolmakers of Flores or to later populations on Luzon. It does reveal that the sea barriers of Wallacea were crossed repeatedly in deep time, before any evidence for modern boats, navigation systems, or maritime societies. Calio therefore creates two histories at once. The first is a firm archaeological history, beginning with 7 worked stones in an ancient river deposit. The second is a vast unwritten history extending around them. Somewhere before those flakes were struck, ancestors approached the edge of another island, entered water, survived a crossing, reached Sulawesi, and learned enough about the new landscape to find stone and use it. Somewhere afterward, their descendants may have endured, disappeared, or been replaced. The tools offer no answer yet. They only move the beginning farther back, into a period where the island's human past becomes older, stranger, and far more difficult to explain. The beginning now moves from the age of the stones to the ground that held them. Calio lies within the Walani Depression of South Sulawesi, a long structural basin where tectonic movement, river systems, erosion, and sedimentation have repeatedly remade the landscape. From the surface, there is little to suggest that this place preserves one of the oldest known episodes of hominin activity in Wallacea. Modern fields spread across the area. Crops grow above buried channels, roads, fences, and daily routines occupy a landscape that once belonged to an entirely different river system. The contrast is almost misleading. Nothing here resembles a sealed cave or a monumental ruin. The evidence survives because ordinary sediment accumulated, hardened, shifted, and was eventually exposed again. That geological setting is central to the discovery. The Walani Depression contains a complicated sequence of sandstone, conglomerate, mudstone, volcanic material, and fossil-bearing deposits formed through the later Pliocene and Pleistocene. Rivers carried sand and gravel through the basin, sometimes flowing strongly enough to move cobbles, sometimes slowing and leaving finer sediment behind. Channels migrated, floodplains expanded and contracted, beds were buried, compressed, tilted, and later cut by erosion. Calio's artifacts came from one part of this long sequence, within sandstone interpreted as ancient river sediment. Their position allowed researchers to ask not merely whether the stones looked old, but whether they belonged to a specific depositional event that could be dated and compared with surrounding layers. This distinction separates a securely excavated artifact from a suggestive object found loose on the surface. A stone lying in a field may have weathered out of an ancient deposit, been moved downhill, carried by a stream, or displaced by modern farming. Its shape can be examined, but its age may remain uncertain. At Calio, the 7 artifacts were recovered from sedimentary context recorded during controlled excavation. Their depth, orientation, relationship to the sandstone, and association with fossils and geological markers were documented. The work does not eliminate every possibility of disturbance, because ancient rivers themselves move objects, but it provides a chain of evidence strong enough to link deliberate stone flaking with early Pleistocene deposits. The fieldwork unfolded across several seasons rather than through a single dramatic moment. Excavations began in 2019 and continued during campaigns in 2021 and 2022. Researchers opened limited areas, removed sediment carefully, mapped finds, collected samples, and examined the stratigraphy exposed around the site. The pace would have seemed slow to anyone expecting treasure. A trench may yield hours of sand, stone, and measurement before a single edge becomes important. Every object must remain tied to its exact location, because the scientific value lies as much in the context as in the artifact itself. A flake taken from the ground without recording its position becomes only a curious stone. A flake embedded within a dated sequence becomes evidence of a vanished presence. Calio also demonstrates how archaeology depends on collaboration between disciplines that speak different technical languages. Stone specialists assess fracture patterns and production methods. Geologists reconstruct how the sediment formed and whether layers have been reworked. Paleontologists identify fossil animals. Dating specialists analyze magnetic signatures and changes within tooth enamel. Surveyors map the basin, while excavators record the smallest spatial relationships. No single observation proves the full case. The argument emerges from convergence intentionally fractured stone, excavated in place, from a deposit whose age is supported by independent geological and chronological evidence. The ancient river that deposited the sandstone may have been both a resource corridor and a destructive force. Flowing water can concentrate useful raw material, carrying cobbles and nodules from distant outcrops. It can also scatter artifacts, abrade edges, and mix objects from different moments. Researchers therefore look for signs of transport. Heavy rounding might suggest that a flake rolled for a long distance in a channel. Sharp edges and limited abrasion can indicate shorter movement or rapid burial. At Calio, the artifacts retain features that permit technological interpretation, although the precise distance between the place where they were struck and the place where they were buried cannot be known with complete certainty. What survives in the record suggests that their movement was not enough to erase the traces of manufacture. The fossil record adds another layer to the basin's history. Sulawesi's extinct animals appear in deposits distributed across the Wallenai region, including the pig Celebacoirus and proboscideans distantly related to elephants. These creatures belong to island lineages shaped by long isolation. Their remains help correlate strata and reveal environmental conditions, but they do not automatically establish a direct relationship with the tool makers. A fossil tooth and a stone flake may occur within the same geological sequence, without proving that a hominin hunted the animal, consumed it, or even encountered that individual. At Calio, no cut-marked bones or clear butchery surfaces have yet been reported from the artifact context. The association is chronological and environmental, not a reconstructed meal. This restraint matters because a sparse site invites the imagination to fill empty space. It is easy to picture a riverside camp, a group processing animals, or a napper sitting beside the water. Any of these scenes could have occurred, but the excavation does not preserve enough evidence to confirm them. There are no hearths, post holes, sleeping areas, or dense scatters of discarded stone. Calio may represent a brief task, a transported handful of flakes, a small napping event, or the eroded edge of a much larger activity area. Scholars still debate how best to interpret such limited assemblages, especially when most of the original landscape has been altered or remains unexcavated. Yet the modest scale of the trench should not be mistaken for the scale of the implication. Archaeological sites are rarely complete snapshots. They are surviving fragments selected by burial, geology, and chance. Much of the ancient ground surface may have vanished. Other artifacts may lie beyond the excavated area, deeper in the basin, or in deposits that have not yet been recognized. The 7 pieces found so far are therefore a minimum record, not necessarily the full extent of activity. Their value lies in proving that at least one episode of deliberate stone use occurred within this ancient landscape. The modern field above Calio makes that deep time especially difficult to feel. Farmers work soil formed from sediments that began accumulating before our species existed. Rain falls into drainage systems that only partly resemble the old rivers. Beneath the cultivated surface, a few sharp stones preserve an action measured in seconds, a blow, a fracture, a flake separating from a core. The person who made that movement disappeared without leaving a known bone. The river changed course. Sediment covered the trace. More than 1 million years later, excavation reopened a small window into the buried channel, and the ordinary ground revealed that someone had already crossed the sea. 7 stone artifacts are an impossibly small foundation for a story this large. They could fit within a modest tray, each separated by labels, measurements, and drawings. There is no polished blade, no symmetrical hand axe, no object whose shape would immediately appear familiar to a modern observer. Most are flakes pieces detached from larger stones by deliberate blows. Their importance lies not in beauty but in fracture, a sharp edge, a striking platform, a bulb created by impact, and the direction of removal preserve the physical logic of a hand that understood how force travels through stone. More than 1 million years after the blow, that logic can still be read. Stone breaks naturally everywhere. It falls from cliffs, is crushed beneath moving sediment, collides in rivers, and fractures under pressure. Archaeologists cannot identify a tool merely because a rock is sharp. They look instead for combinations of features unlikely to result from random damage. A controlled strike usually begins on a chosen surface. The force creates a point of percussion and travels through the stone, producing a characteristic curved fracture. Ripples may spread across the detached face. The remaining core can preserve a negative scar showing where the flake once belonged. When several removals follow an organized pattern, the case for intentional napping becomes stronger. The Calio assemblage preserves such evidence. The artifacts were produced from silicious stone, a material capable of yielding durable, sharp edges when struck correctly. Researchers identified hard hammer freehand percussion, meaning that the napper held or supported a core and struck it directly with another stone. This is among the simplest known methods of stone production, but simple does not mean accidental. The angle of the blow, the choice of platform, the quality of the raw material, and the force applied all affect whether the stone produces a useful flake or shatters unpredictably. Skill can exist in technology that leaves no ornament and requires no elaborate preparation. Some pieces indicate that the core was rotated as flakes were removed from more than one direction. That detail reveals flexibility. The maker was not merely hammering a rock repeatedly at the same point. The stone was inspected, repositioned, and used as a three-dimensional object whose surfaces offered changing opportunities. One artifact has been interpreted as a Kombewa-type flake. Such a flake is removed from the ventral face of an earlier flake, so its form can preserve part of the earlier flake's curvature on one surface and a newer fracture on the other. A detached piece was itself treated as a new core. This does not establish a standardized Kombewa industry or a complex technological tradition at Calio. With only 7 artifacts, every broad conclusion must remain cautious. The piece may record an intentional strategy, an opportunistic decision, or a short sequence produced while testing a stone. Archaeologists can describe the mechanics more confidently than the purpose. What survives in the record suggests controlled reduction, yet it does not reveal whether the napper learned a formal sequence from others or carried practical knowledge shared within a small population. Stone napping was probably learned, but its social setting has vanished. The sharp flakes would have been useful in many tasks. A fresh siliceous edge can slice flesh, open tough plant material, scrape bark, trim wood, cut tendons, or work hide. It may lose sharpness quickly, but another edge can be produced within moments if suitable stone is available. Flakes are compact, versatile, and often more efficient than objects that look more impressive. A hominin moving through an unfamiliar island did not need a beautifully shaped implement to transform food or raw material. A small cutting edge could be enough. No specific function, however, has been demonstrated for the Calio pieces. There is no secure microscopic residue showing what they contacted, no confirmed use-wear pattern tying them to one task, and no animal bone-bearing cut marks directly associated with the assemblage. The stones cannot yet be called hunting tools, butchery knives, woodworking implements, or plant processing equipment as though those uses were established. They are artifacts of manufacture first and tools only in a broader probable sense. Some flakes may have been used, others may have been waste from producing another edge that has not survived or has not been found. That uncertainty protects the evidence from a common distortion. A stone flake beside a fossil animal can easily become, in retelling, a weapon beside prey. Soon the unknown hominin is imagined pursuing pigs or bringing down an elephant relative at the river's edge. Calio provides no such scene. The island's ancient fauna and the artifacts occupied the same broad world, but their direct interaction remains unproven. Even the most vivid reconstruction must stop before the moment of contact. The flakes establish technical behavior. The fossils establish an ecological setting. The missing link between them is real. Raw material choice may offer another glimpse of decision-making. River systems can expose stone from several sources. mixing durable silicious pieces with softer or less predictable rock. A napper capable of recognizing quality would select material that fractures cleanly. Yet researchers cannot reconstruct the entire procurement journey from 7 artifacts. The stone may have been collected close to the ancient channel, transported from elsewhere in the basin, or carried as a core or finished flake. Transport would imply anticipation of future need. Immediate use would still show rapid assessment of local resources. The assemblage is equally silent about frequency. 7 pieces could represent one brief episode, several visits compressed within sediment, or a fragment of a larger scatter destroyed by erosion. A single napper might have produced them in minutes. Several individuals might have contributed over a longer interval. The site preserves action without duration. A thin layer may contain events separated by generations, while one brief task can leave more debris than years of movement elsewhere. Even so, the artifacts draw attention back to hands. Whatever species made them, its fingers could stabilize stone, its eyes could evaluate angles, and its nervous system could coordinate a forceful, precise blow. The maker understood enough of the island to obtain workable material and enough of fracture to create sharp edges deliberately. These abilities are modest but not trivial. They belong to a lineage capable of carrying learned techniques across a boundary of sea. The 7 stones do not tell us what the travellers looked like, what they ate, how many crossed, or whether they intended to reach Sulawesi. They do not preserve a voyage. They preserve what happened after arrival. Someone encountered this landscape, chose stone from it, or brought stone into it, and struck with control. The evidence is small enough to hold in 2 hands, yet within those pieces lies the only direct gesture left by the island's earliest known toolmakers. Everything else, the body, the voice, the root, and the reason has disappeared. The age of Calio does not rest on one number calculated from one instrument. It emerges from several independent lines of evidence, each with its own strengths, assumptions, and uncertainties. A claim this old must survive more than visual resemblance. Stone tools cannot be dated by shape alone, especially when simple flake technology changed little across immense spans of time. A sharp piece made 1 million years ago can resemble one made 10,000 years ago. To place the Calio artifacts within the early Pleistocene, researchers had to date the geological world that enclosed them. The first part of that work came from paleomagnetism. Earth's magnetic field has reversed many times, with magnetic north and south exchanging positions. When fine mineral particles settle within sediment, some align with the magnetic field existing at that moment. Once buried and stabilized, they can preserve a record of that orientation. Scientists sample the sediment, measure its remnant magnetism, and compare the pattern with the established chronology of global magnetic reversals. The method does not produce an exact birthday for each grain of sand, but it can place a layer within a known interval of geological time. A Calio, the magnetic signature, helped show that the artifact-bearing deposits belong to a period older than the most recent major reversal, when the field shifted into its present orientation about 773,000 years ago. This placed the relevant sediments within the Matuyama reversed chron, a long interval extending through much of the early Pleistocene. Paleomagnetism therefore provided a broad temporal framework, but broad frameworks require narrower anchors. For that, the researchers turned to a fossil tooth recovered from the same geological sequence. The tooth belonged to Celebacorus, an extinct pig lineage unique to Sulawesi. Its presence is valuable for more than reconstructing the island's fauna. Tooth enamel and dentine can preserve measurable traces of radiation exposure accumulated after burial. Two methods were combined: uranium series analysis and electron spin resonance, often shortened to ESR. Together, they can estimate how long a tooth has remained within sediment, though the calculation depends on how uranium entered the tissue and how the surrounding radiation environment changed over time. Electron spin resonance measures trapped electrons created by natural radioactivity. Minerals within tooth enamel receive small doses of radiation from uranium, thorium, potassium, cosmic rays, and other sources in the surrounding sediment. Over time, electrons become trapped within defects in the crystal structure. The longer the exposure continues, the larger the accumulated signal tends to become. By measuring that signal and estimating the annual radiation dose, researchers can calculate an age. The principle seems simple, but burial environments rarely are. Water moves through sediment. Uranium can enter a tooth gradually, rather than at the moment of burial. Sediment chemistry can change. Each of these processes affects the dose estimate. Uranium series analysis helps reconstruct that history. Uranium isotopes decay at known rates into daughter products, and their proportions provide information about when uranium was taken up by the fossil. Because teeth usually contain little uranium while an animal is alive, much of it enters after burial through groundwater. Researchers model this uptake rather than assuming it occurred instantly. Combining uranium series measurements with ESR allows them to test different uptake scenarios and produce an age estimate with a defined uncertainty. For the Calio sequence, the modeled mean age associated with the fossil sample was approximately 1.26 million years, with an uncertainty of about 220,000 years. This is the source of the range that must be handled carefully. Subtracting the uncertainty produces a lower boundary of roughly 1.04 billion years. Adding it gives an upper possibility near 1.48 million years. The result does not mean the tools were certainly made 1.26 million years ago on a specific day within that distant interval. It means the best supported model centers there, while the available evidence permits a range around it. The phrase at least 1.04 million years old is therefore more accurate than simply calling the artifacts 1.5 million years old. The upper figure is possible, not fixed. Scientific dating often becomes distorted when uncertainty is treated as weakness or removed for dramatic effect. In reality, the uncertainty is part of the result. It tells us how precisely the surviving evidence can constrain the past. Calio remains extraordinary even at the youngest end of the range. A minimum age of the 1.04 million years is enough to transform the known timeline of Sulawesi. The strength of the chronology comes from convergence. Paleomagnetism places the deposits within an ancient reversed magnetic interval. The fossil tooth provides a numerical age through combined ESR and uranium series analysis. The stratigraphy connects those results to the sandstone containing the artifacts. No method is infallible, and future work may refine the model, but the techniques do not stand alone. They reinforce one another within a geological sequence that can be examined directly. Researchers must also ask whether the artifacts and dated fossil truly belong to the same depositional history. Ancient rivers can erode older layers and redeposit fossils into younger sediment, producing what geologists call reworking. A fossil may therefore be older than the bed in which it is found. Conversely, later disturbance can move objects downward. The Calio team examined sedimentary context, stratigraphic relationships, and the physical condition of finds to assess these possibilities. The published interpretation supports an early Pleistocene age for the artifact-bearing layer, but the evidence remains open to testing as more of the basin is excavated. Additional dates would be especially valuable. One tooth can provide a powerful anchor, yet multiple independently dated fossils or sediments from several levels could narrow the range and reveal whether the artifacts belong to one event or a longer sequence. Volcanic minerals, if present in suitable positions, might offer other chronological methods. More paleomagnetic samples could clarify local stratigraphy. Archaeology advances by making an initial result increasingly difficult to explain away. The dating also forces a comparison with other islands. At Flores, stone tools from Sulawesi date to about 1.02 million years ago. Calio is at least comparable in age and may be older. On Luzon, the Kalinga evidence is younger, between roughly 777,000 and 631,000 years ago. These numbers do not establish a simple eastward migration route, but they reveal that oceanic islands were being reached repeatedly during the Pleistocene by hominins whose identities remain uncertain. A few magnetic minerals and one fossil pigtooth have therefore changed the scale of the story. The artifacts themselves show that someone struck stone. The dating methods show when that action occurred. Between the measured electron signal, the reversed magnetic field, and the layered sandstone, the ancient river gives up a narrow part of its chronology. It cannot identify the napper or describe the crossing, but it places both beyond 1 million years ago, where the mystery becomes not merely maritime, but almost unimaginably old. The date fixes the action within deep time, but a number alone cannot restore the world in which it happened. Early Pleistocene Sulawesi was not simply the modern island with fewer roads and more forest. Rivers followed different courses, coastlines shifted with changing sea levels, volcanic activity reshaped valleys, and tectonic movement continued to lift and fold the land. Calio lay within a river system that carried sand, gravel, cobbles, and fragments of stone through the Wallanai Basin. Water created opportunities, moved raw material, concentrated animal traffic, and repeatedly erased the surfaces on which daily life occurred. The landscape that preserved the tools was also capable of destroying nearly everything around them. The ancient river may have been broad and seasonal, expanding during heavy rain and contracting into narrower channels during drier months. Banks would have shifted after floods. Sandbars appeared and vanished. Gravel beds exposed stones suitable for napping, while wooded margins offered shade, plant foods, and materials that left almost no archaeological trace. The exact climate at the moment the flakes were made cannot be reconstructed from 7 artifacts alone. Sulawesi's position near the equator suggests warmth, but rainfall patterns changed with monsoons, global glacial cycles, and local topography. A tropical island can contain wet forests, open woodland, grassier valleys, and dry seasonal zones. The toolmakers may have known a mosaic rather than a single endless jungle. That diversity matters because movement through Sulawesi is difficult even today. Mountain chains divide the island, peninsulas project in different directions and are separated by deep gulfs. Interior basins can feel isolated from nearby coasts. Rivers provide routes, but they can also become barriers during floods. A newly arrived population would not have encountered an empty, gentle refuge. It would have entered a large, geologically restless island with unfamiliar seasons, unfamiliar animals, and resources distributed unevenly across complicated terrain. The animal world was unusual. Sulawesi had been isolated long enough for its fauna to develop distinctive forms. The extinct pig Celebacurus, whose tooth helped date the Calio sequence, belonged to a lineage found nowhere else. Ancient proboscideans also reached the island and evolved under conditions unlike those on the mainland. Other mammals arrived at different times, while many familiar continental species never crossed the surrounding seas. The ecosystem was not a reduced copy of Borneo or Java. It was an island experiment assembled through rare dispersal events and prolonged separation. Those animals offer an important comparison with the hominins, pigs, proboscideans, rodents, and other terrestrial creatures could not have walked across the Makassar Strait either. Their ancestors must have crossed water somehow, perhaps on floating vegetation, through accidental rafting, or by using shorter island steps during favourable conditions. The fossil record shows that improbable dispersal was possible long before hominins appeared at Calio. It does not show that human arrival happened in the same way, but it prevents the sea barrier from being treated as absolute. Wallacea was difficult to enter, not impossible. Once established, island animals often changed. Large species sometimes became smaller when resources were limited and predators scarce. Small species could become larger when competition shifted. Bodies, teeth, diets, and behavior adapted to local conditions over generations. Sulawesi's size and ecological complexity meant that these processes would not necessarily resemble those on smaller Flores. Even so, prolonged isolation could have shaped any hominin population that remained. That possibility is compelling, but no bones from Calio reveal whether the toolmakers changed physically after arrival, or whether they belong to a population newly arrived from elsewhere. Daily survival can only be approached indirectly. Fresh water was likely available along the river system. Edible plants, tubers, fruits, insects, shellfish, small animals, and scavenged or hunted meat may all have formed part of the diet, but none can be assigned securely to the Calio occupants. Tropical organic remains decay quickly, especially in open-air settings. Wood, fibre, leaves, skin, and most food waste disappear. Stone survives because it is exceptional in its durability, not necessarily because stone dominated every activity. The visible technology may represent only a thin mineral residue of a far richer material culture. A flake could have opened plant stem, cut roots, scraped bark, or processed animal tissue. A wooden digging stick might have been more important in daily life, yet leave no trace. Containers could have been made from bark, leaves, shell, or woven fibre. Natural shelters, temporary windbreaks, and simple sleeping platforms may have existed and vanished completely. No single explanation fully accounts for what these hominins carried, made, or knew. Archaeology is forced to reconstruct a way of life from the objects least likely to decay. Fire presents another uncertainty. By more than 1 million years ago, some hominin populations elsewhere may have used fire at least occasionally. But Calio has produced no secure hearth or burned feature tied to the artifacts. It would be unsafe to place controlled flames beside the river merely because fire seems useful. The same caution applies to hunting. Sulawesi's endemic pigs and proboscideans shared the landscape, but there are no confirmed cut marks from Calio showing that the toolmakers butchered them. They may have hunted, scavenged, gathered, fished, or combined many strategies. The surviving evidence does not choose among them. Predation and competition are also difficult to judge. Island ecosystems often contain fewer large mammalian carnivores than continents, but crocodiles, snakes, raptors, disease, injury, and unstable rivers would still have posed risks. The absence of familiar predators does not make the environment safe, nor does isolation guarantee abundant food. A small founding population could be vulnerable to drought, storms, failed reproduction, and the loss of practical knowledge if experienced individuals died. Reaching the island was only the first challenge. Remaining there required repeated success across seasons and generations. The river corridor may have helped make that possible. Water attracts animals and plants, exposes stone, and creates recognizable routes through difficult country. Hominins could return to favorable locations, teaching others where raw material occurred and when resources became available. Even a simple flake industry implies continuity of learned action. Someone knew that a particular stone would fracture well. Someone controlled the blow. If more than one generation occupied the basin, that knowledge had to pass from person to person without writing, maps, or durable structures. Yet Calio does not reveal whether such continuity existed. The 7 artifacts may belong to a lasting population, a short-lived colony, or a single episode before disappearance. The basin's fossils demonstrate that animals could survive and evolve on Sulawesi for long periods. The tools show that hominins entered the same isolated world. Between those facts lies an enormous unknown. The island offered water, stone, food, and space. But it also enclosed its inhabitants behind deep channels. Whatever happened after arrival unfolded beyond the reach of the record, under tropical rain, beside rivers whose courses no longer exist. The river world around Calio helps explain how hominins could live on Sulawesi, but it does not explain how they reached it. That problem returns us to the sea and to a common misunderstanding about Ice Age geography. When global temperatures fell and continental ice sheets expanded, sea level dropped dramatically. Vast coastal plains emerged across Southeast Asia. Sumatra, Java, Borneo, and the Malay Peninsula became parts of a single landmass known as Sunda. From the perspective of a modern map, many islands disappeared into one extended continent. It is tempting to imagine that Sulawesi did the same, waiting to be reached across exposed ground. It did not. The reason lies beneath the water. Much of the Sunda shelf is shallow, so lowering sea level by around 120 meters can uncover enormous areas. The channels around Sulawesi are different. They include deep marine basins and tectonic trenches formed by the collision and movement of crustal blocks. West of the island, the Makassar Strait descends to depths measured in thousands of meters. No Pleistocene fall in sea level could expose its floor. Coastlines shifted outward, distances narrowed, and smaller islands may have enlarged. But a genuine body of water remained between Sulawesi and the continental world to the west. At times of maximum low sea level, Borneo and Sulawesi may have been separated by roughly 50 kilometers at their nearest relevant approach. The exact distance depends on how ancient shorelines are reconstructed, and local geography changed through tectonics as well as glacial cycles. 50 kilometers is therefore not a single permanent measurement, yet even a shorter estimate preserves the essential fact the gap did not close. A traveller could not unknowingly continue along a plain and discover that the plain had become Sulawesi. There had to be a point of departure, a period spent afloat, and a landfall on the other side. This makes the phrase deep water crossing precise in a geological sense, though it should not be confused with proof that the travellers navigated over the deepest part of the strait. They may have followed a route involving islands, coastal projections, or narrower channels than those visible today. Their path may have taken advantage of currents or seasonal winds. The point is not that they necessarily crossed a single, uninterrupted 50-kilometre span over abyssal water. The point is that every plausible route still required crossing water that never became land. Visibility adds another layer of uncertainty. From a low shoreline, the curvature of Earth limits how far a person can see. Mountains on Sulawesi could be visible from considerable distances under clear conditions, while haze, rain, and sea spray could erase them. Clouds may gather above high ground and hint at an island beyond the horizon. Birds, floating vegetation, smoke from natural fires, or changes in wave patterns might also suggest land. None of these clues proves that the Calio travellers knew where they were going. They simply show that an unseen or barely visible destination is not the same as a completely unknowable one. The Pleistocene shoreline itself has vanished. When sea level rose, coastal camps, departure points, and landing places were submerged. Waves and currents reworked much of the evidence. If hominins paused on an exposed shelf before entering the water, their traces may now lie beneath sediment far offshore. If they used wood, bark, reeds, vines, or natural rafts, those materials would almost certainly have decayed. Archaeologists are left with an arrival recorded inland and a route erased by the very sea that made the arrival remarkable. Lower sea level still mattered. It reduced the width of crossings, exposed additional islands, altered currents, and changed where rivers entered the sea. A storm-driven raft travelling from Borneo during a glacial low stand might have faced a shorter journey than the same raft would today. Coastal populations could also have moved gradually across newly exposed plains before reaching the final water barrier. The sea level fall did not solve the crossing, but it may have made an improbable event less improbable. It also changed the ecological stakes. A wider Sunda landmass could support hominin populations closer to the edge of Wallacea. Rivers flowing across the shelf may have carried trees and vegetation into coastal waters during floods. Tropical storms could tear large mats of roots and soil from riverbanks. Animals are known to survive accidental rafting events on such debris. Hominins living near estuaries might have encountered natural floating platforms regularly, whether they used them deliberately or were swept away upon them. The geography created opportunities without providing an explanation. No direct evidence identifies the departure coast. Borneo is a strong candidate because of proximity and because later, drift modelling suggests routes from there could reach Sulawesi under certain conditions. Yet the model does not transform possibility into history. Northern routes involving the Philippines, southern approaches through other islands, and repeated entries from different directions cannot be excluded. Coastlines and currents were dynamic, and the earliest archaeological site found on Sulawesi need not lie near the first landing place. The sea barrier also complicates the meaning of the Calio population. If only one or two individuals arrived accidentally, they could not establish a lasting community. A viable population would require enough people, a group containing both sexes, repeated arrivals, or contact across the water over time. Planned movement could increase those chances, but accidental dispersal might also occur more than once across thousands of years. Archaeology currently cannot distinguish a single founding event from many rare landfalls. 7 stone artifacts cannot reveal the number of voyages behind them. This is why the crossing remains difficult to classify. It may have been intentional without involving navigation in the modern sense. Hominins might have pushed onto floating material to reach a visible island, only to be carried farther than expected. They might have used simple floats near shore and survived an accidental long drift. A storm may have converted coastal behaviour into an ocean passage. the categories of deliberate voyage and helpless accident can blur, especially when the travellers left no account and their technology was made from perishable material. What can be rejected is the comforting image of a lost bridge of land. Sulawesi was not merely cut off after its first inhabitants arrived. It was already an oceanic island when they came. The Makassar Strait remained open, deep, and ecologically powerful through the lowest sea levels of the Pleistocene. It filtered animal movement, shaped evolution, and preserved a sharp boundary within the region. More than 1 million years ago, hominins crossed that boundary by some means still unknown. Nothing in the surviving record tells us how they crossed that final blue distance. The exposed plains of Sunda may have brought them to the water's edge, but the final part of the journey began where walking stopped. The point where walking stopped is also where scientific reconstruction becomes strangely dependent on wind, current, and chance. Because no vessel survives and no coastline camp can be tied to the first arrival, researchers have tried to model the sea itself, instead of asking what kind of craft the Calio hominins possessed. They begin with a narrower question: if people or animals entered the water from different parts of the surrounding region, where might the currents have carried them? A 2021 drift modelling study examined possible accidental routes to Sulawesi from Borneo, Mindanao, and the Banda Island chain. Its results do not identify the true voyage, but they offer the most concrete test yet of whether an unplanned crossing could have happened without sophisticated navigation. The model reconstructed ancient coastlines under lower sea levels and combined them with simulated currents, winds, and seasonal ocean conditions. Virtual particles were released from possible source areas and allowed to drift. Some failed to reach land. Others moved away from Sulawesi or remained trapped in unhelpful circulation patterns. A smaller number arrived. Among the tested origins, Borneo emerged as the most plausible source for successful drift towards Sulawesi. That outcome fits the geography already suggested by the narrowed Western Gap, but it adds something more. The sea was not a featureless obstacle. It contained routes of movement, invisible from shore but capable of carrying floating objects across the barrier. In some simulated cases, the crossing from Borneo could take roughly 3 to 8 days. That is short enough to imagine survival, but long enough to make every detail important. Fresh water becomes urgent. Exposure to sun, wind, and spray drains strength. A floating mat of vegetation may break apart. A simple log or bundle of branches offers little protection from waves. A group that entered the water accidentally would have no guarantee that land lay ahead. Even if Sulawesi's mountains or cloud formations became visible after a day or two, the travellers might be unable to steer toward them. The model shows that currents could deliver them. It does not show that they controlled the journey. 3 to 8 days also represents a modelled range, not a preserved travel diary. Ancient wind systems cannot be reconstructed perfectly. Currents vary by season, weather, and sea level. The exact shoreline more than 1 million years ago remains uncertain, while tectonic movement has altered the positions and shapes of coasts. A simulation simplifies many local effects, and its virtual particles do not become hungry, frightened, injured, or exhausted. Scholars still debate how closely such models can approximate rare biological dispersal events. Their value lies in demonstrating plausibility, not in replaying the crossing with certainty. The Borneo scenario is especially compelling because large tropical rivers can send debris far offshore. Floods undermine banks, uproot trees, and release tangled masses of vegetation held together by roots and soil. Such rafts can carry reptiles, mammals, insects, and sometimes enough fresh plant matter to provide temporary food or moisture. A hominin group living near an estuary might step onto a floating mass while gathering, crossing a channel, or escaping rising water. A storm surge could detach it before the passengers understood what was happening. Once caught by an outward current, the shoreline might recede quickly. Yet accidental rafting does not require every passenger to be entirely passive before departure. Hominins could have used logs, branches, or vegetation to cross rivers and lagoons. A coastal activity familiar in shallow water might become dangerous when winds or tides shifted. A float meant for a short crossing could be carried beyond control. This middle ground matters because the surviving evidence cannot divide behavior neatly into deliberate seafaring and pure helplessness. The journey could begin with intention and end as drift. It could begin as accident and later involve attempts to paddle, balance, or redirect the raft with branches. The model also suggests that low sea level was helpful, but not the only condition producing successful landfall. Narrower distances increase the probability of reaching Sulawesi, yet ocean circulation sometimes allowed arrivals under other sea level states. This complicates the idea that crossings occurred only during extreme glacial lows. Hominin dispersal could have depended as much on season, storm patterns, and the point of departure as on the absolute width of the strait. A rare combination may have opened a temporary pathway across water without leaving any visible path behind. Other proposed source regions performed less successfully in the simulations, but they cannot be dismissed entirely. Mindanao lies to the north, connected to Sulawesi through a complex maritime zone of smaller islands and channels. The Banda region to the southeast presents other possible stepping routes. Different current reconstructions, coastlines, or starting points could alter the results. More importantly, the earliest site currently known at Calio does not prove that the first landing occurred nearby or even on the same peninsula. People could have arrived elsewhere and moved inland over generations. The Borneo route is the strongest modelled candidate, not a solved itinerary. A successful drift also raises the question of who survived together. One individual reaching shore would leave no lasting population unless other arrivals followed. 2 or 3 people might survive for a time but remain demographically fragile. A larger group carried on a broad vegetation raft would have better prospects, yet large accidental rafts may be rarer. Repeated events across centuries or millennia could gradually introduce enough individuals to establish a population. The archaeological record cannot show whether Calio represents descendants of one extraordinary crossing or the cumulative result of many unlikely journeys. The animals of Sulawesi make repeated chance events easier to imagine. Their ancestors crossed water without boats, and some lineages became established despite the improbability of any single voyage. Hominins, however, add culture to the equation. They could cooperate, share food, hold on to floating material, help exhausted companions, and use sharp tools after landing. These abilities might increase survival without requiring planned navigation. The crossing could therefore be accidental in origin but distinctly hominin in outcome. No part of the model proves that this is what happened. It cannot tell whether the Calio toolmakers came from Borneo, how many travelled, what supported them, or whether they saw Sulawesi before entering the water. It does not eliminate purposeful voyaging, and it does not recover a lost raft from the early Pleistocene. What it does is narrow the mystery. That possibility is unsettling because it requires no map. The sea between Borneo and Sulawesi was dangerous, but under certain conditions it could function as a conveyor rather than an absolute wall. For several days, unseen currents may have carried living passengers eastward. At the end of that drift, if fortune held, the horizon would darken into mountains, forests, and an island where sharp stone could be struck beside an ancient river. The darkening horizon does not tell us what carried the travellers toward it. That missing object raft, log, vegetation mat, or something deliberately assembled stands at the centre of the Sulawesi problem. The archaeological evidence proves arrival, but it preserves no means of arrival. Wood decays, bark separates, vines rot, and woven fibres disappear. Even under exceptional conditions, a simple early Pleistocene float would have almost no chance of surviving for more than 1,000,000 years. The absence of a vessel is therefore expected, yet it leaves every reconstruction dependent on indirect clues. One possibility is that the crossing required no constructed craft at all. Tropical floods can tear sections of riverbank into the sea. Trees remain locked together by roots, mud, and climbing plants, forming unstable rafts large enough to carry animals. Storms and earthquakes can add more debris, while swollen rivers push it beyond coastal shallows. A hominin caught on such a mass might have had little control over departure. Natural rafting has often been invoked to explain terrestrial animals on oceanic islands. Sulawesi's endemic fauna shows that improbable dispersal occurred repeatedly over geological time. Yet an animal arrival and a hominin colonization are not identical problems. A pregnant female or a small breeding group can establish some species under favourable conditions. Hominins require social cooperation, learned technology, access to water, and a population large enough to persist. Still, the animal record demonstrates that floating vegetation can cross marine barriers. It turns an apparently impossible journey into a rare event governed by storms, currents, survival, and chance. A second possibility involves natural objects used deliberately. Logs, branches, bamboo-like vegetation, or buoyant plant bundles could help people cross rivers, estuaries, and short coastal channels. Such behaviour does not require a designed boat. It may begin with holding onto a trunk, pushing a floating mass, or balancing on pieces of wood. Experience in shallow water could teach that some materials support weight better than others. A group might use them for fishing, gathering shellfish, reaching a sandbar, or moving across a flooded channel. If tides or winds then carried the float offshore, an intended local crossing could become an unintended voyage. This blurred boundary between accident and intention is easy to overlook. Modern language encourages a simple choice: either the travellers were helpless castaways or purposeful mariners. Early hominin behaviour may not fit either category. They could select floating material without understanding ocean circulation. They could push away from shore while aiming at visible land, then lose control. They could survive a storm by clinging to debris and later use branches to influence direction. Intent may have existed at one stage of the journey and disappeared at another. No single explanation fully accounts for the possibilities. The third possibility is some form of deliberately assembled craft. This need not resemble a canoe. A few logs tied with vines, a bundle of reeds, or branches trapped within a wooden frame could create enough buoyancy for several individuals. Such a structure might be built for rivers before ever being used at sea. The materials and tools required were not necessarily beyond early Pleistocene hominins. Sharp flakes could cut plant fibres or trim branches, although no Calio artifact has been shown to perform those tasks. Cordage can be made without leaving durable evidence. Planning a simple float is conceivable, but conceivability is not proof. There is no boat, paddle, rope, shaped timber, launch site, or specialized woodworking tool from Calio. Nor is there evidence that the makers understood tides, winds, stars, or distant routes. Calling them sailors would imply a level of maritime practice the archaeological record does not establish. Even the term raft can become misleading if it creates an image of a stable platform constructed for exploration. The safest conclusion is narrower some form of flotation must have been involved, whether natural, modified, or deliberately built, because the crossing could not be completed by walking. Swimming alone is an unlikely explanation for a substantial deep-water passage. Hominins can swim, and short crossings may be possible, but distances of many kilometers, strong currents, exposure, and the need to establish a population make unaided swimming a poor general model. A current can carry swimmers away from their target faster than they can compensate. Perhaps individuals entered the water close to a floating object and alternated between holding, kicking, and resting. Again, the categories overlap. What matters is that survival likely depended on buoyancy, even if no recognizable craft existed. Demographic modeling adds another constraint. Studies comparing accidental dispersal with planned colonization show that a viable founding population is difficult to create through a single random event. A small group may reach shore and still disappear within one generation. Successful settlement becomes more likely if the travelers include several adults of different sexes, if repeated arrivals occur, or if some continuing contact exists with the source population. Planned voyages could transport larger and more balanced groups, but repeated accidental drifts over thousands of years might eventually achieve the same result. Archaeology cannot yet determine which process occurred on Sulawesi. The Calio tools also do not prove that a permanent colony followed immediately after the first landing. The artifacts could belong to descendants of a population established long before, to a short-lived group that vanished soon afterward, or to one of several separate arrivals. A crossing successful enough to leave 7 flakes is not automatically a colonization successful enough to last millennia. The distinction matters because arrival is an event, while settlement is a demographic process. The sea had to be crossed once for someone to reach the island. It may have needed to be crossed many times for a population to endure. Purposeful voyaging remains possible because the evidence is incomplete. Early hominins were capable of foresight in stone procurement, coordinated movement, and adaptation to varied environments. On other islands, repeated occupation suggests that water barriers did not defeat them entirely. Yet there is no reason to turn possibility into a heroic maritime narrative. Intelligence does not require advanced seafaring. An accidental dispersal is not a lesser explanation merely because it lacks drama. A storm-driven arrival could transform evolutionary history without anyone choosing the destination. At Calio, the surviving stones begin only after the water crossing is over. They show people adapting to land, not mastering the sea. Somewhere beyond the vanished coastline, organic materials carried living bodies across a deep channel and then disappeared from the record. Perhaps roots and branches broke apart in the surf. Perhaps a crude float was abandoned on the beach. Perhaps nothing more than a storm-torn mass of vegetation ever existed. The island keeps the result and loses the mechanism. More than 1 million years later, the crossing can be modelled, compared, and imagined, but the object beneath the travellers remains invisible. The invisible object beneath the travellers is matched by another absence on land. Calio has produced stone tools, fossils of island animals, and a geological sequence deep enough to place human activity beyond 1 million years ago. But it has yielded no hominin bone. There is no tooth, jaw, skull fragment, or limb element that can be compared with known species. The makers enter the record through technique alone. They struck stone, understood fracture, and lived long enough after arrival to leave artifacts beside an ancient river. Everything about their bodies remains unknown. The most obvious candidate is Homo erectus. By the early Pleistocene, populations commonly assigned to that species were established on Java, part of the Sunda world west of Wallacea. They had dispersed far beyond Africa, occupied varied environments, and possessed stone technology fully capable of producing the simple flakes found at Calio. Java also provides the nearest well-known source population within the appropriate broad period. It is therefore reasonable to consider Homo erectus, or a closely related population, when imagining who approached the water from the west. Reasonable, however, is not the same as demonstrated. The label Homo erectus covers fossils spread across enormous distances and long spans of time, and specialists continue to debate how much biological diversity belongs within it. A population leaving Sunda may have differed from the better-known individuals preserved on Java. Once isolated on Sulawesi, descendants could have followed their own evolutionary path. Even if the original travellers belonged to a Homo erectus-related lineage, fossils found hundreds of thousands of years later might not fit neatly into the same category. Without anatomy, the name remains an informed possibility rather than an identification. Calio also offers no basis for calling its makers Denisovans. Denisovan ancestry survives in some present-day populations of island Southeast Asia and Oceania, proving that complex encounters occurred somewhere in the wider region during a much later period. Yet the earliest secure Denisovan evidence is vastly younger than Calio, and no Denisovan fossil or genome has been recovered from Sulawesi. Genetic legacy cannot be projected backward for nearly 1 million years to name an unknown toolmaker. The former topic guidance about Denisova cave, high-altitude adaptation, and Denisovan disappearance belongs to another story entirely. Nor can the Calio population be identified as Homo floresiensis. That species is known from Flores, where distinctive small-bodied fossils occur much later, and older remains at Matamenga suggest a long local evolutionary history. Sulawesi and Flores are separated by water, differ greatly in size and ecology, and need not have contained the same lineage. Similar early dates for occupation do not prove common identity. Separate populations may have reached different islands from different sources, or one widespread ancestral group may have diversified after several crossings. The evidence remains incomplete. The same caution applies to Homo luzonensis, named from fossils in Calio Cave on Luzon. Its unusual combination of anatomical features confirms that island Southeast Asia once contained human forms absent from older textbooks. It does not provide a face for Calio. Luzon lies far to the north. Its fossils are much younger, and no direct connection has been demonstrated between the two islands. Using one island species to fill another island's fossil silence would replace uncertainty with resemblance rather than evidence. A more unsettling possibility is that Sulawesi sheltered a lineage never discovered elsewhere. Large oceanic islands can isolate populations for immense periods. Genetic drift, local diets, disease environments, population bottlenecks, and ecological pressures can gradually produce distinctive anatomy. Sulawesi is much larger than Flores and contains varied habitats, so any evolutionary response could have been complex, rather than a simple trend toward smaller bodies. A resident population might have remained broadly similar to its ancestors, developed unique traits, or disappeared before leaving fossils in places archaeologists have examined. Tropical fossil preservation makes that disappearance easier. Warmth, rainfall, acidic soils, plant roots, microbial activity, river transport, and tectonic disturbance can destroy bone rapidly. Open-air river settings are especially selective. A skeleton may be scattered, dissolved, crushed, or carried away before burial. Caves often preserve fossils better, but early Pleistocene occupants need not have used caves in areas later explored, and suitable deposits may remain sealed beneath sediment. The absence of bones at Calio does not mean no bodies ever lay within the basin. It means geology did not preserve, expose, or surrender them to current excavation. Search history also matters. Sulawesi is enormous, while excavated windows into its deep Pleistocene record remain small. Archaeologists work where deposits are visible, accessible, and datable. Dense vegetation conceals outcrops. Farming and construction disturb sediments. Tectonic uplift may raise ancient deposits into hills, while erosion removes others completely. Fossils could remain in unexplored caves, buried valleys, or museum collections awaiting recognition. Calio may be the first clear signal of a much larger record rather than an isolated anomaly. Stone technology cannot solve the identity problem because simple flakes are not exclusive to one species. Homo erectus made them, but so did other hominins, including much later Homo sapiens. Tool traditions can persist, converge, or change according to available raw material and immediate need. A small sharp flake from riverstone may be the sensible solution for many different bodies and minds. The Calio artifacts reveal learned action, not a diagnostic culture that can be assigned securely to a species. Even behavior offers limited help. Crossing water may suggest planning, but accidental drift could involve no maritime intention. Survival on an island indicates adaptability, yet adaptability is widespread among hominins. Core rotation and controlled percussion show competence, but not language, symbolic thought, or a particular brain size. Every attempt to infer anatomy from these behaviors risks turning broad human capacities into species labels. No genetic evidence reaches this far back in Sulawesi. Tropical heat accelerates DNA decay, and 1 million years lies far beyond what can normally be expected from such conditions. Future protein analysis might recover broader evolutionary signals from enamel if a suitable tooth is found. But even that would require exceptional preservation. For now, classification cannot begin with molecules any more than with bones. The population is defined only by location, age, and activity, a scientific outline built around what is missing. The unknown makers therefore occupy an unusual position. They are neither imaginary nor identifiable. Their existence is established more firmly than their name. A blow preserved in stone proves that hands were present. Geological dating places those hands in the early Pleistocene. Island geography proves that their lineage crossed water. Beyond that, the silhouette remains empty. It may eventually be filled by a tooth from the Wallanai Basin, a skull fragment from a cave, or ancient proteins preserved where DNA cannot survive. Until then, Calio records a population without a face, standing at the beginning of Sulawesi's human history and refusing every familiar name. The refusal of every familiar name becomes easier to understand when the neighbouring island of Flores is brought into view. Flores once seemed too isolated, too small, and too far inside Wallacea to have been reached by hominins before modern humans. Then stone tools from Woloseg were dated to about 1.02 million years ago. The near match in age is striking, though the relationship between the populations remains wholly unknown. on two different oceanic islands, separated from the Sunda continent by permanent water. Toolmakers were present at roughly the same depth of time. It shows that Sulawesi was not an isolated exception. Early hominins entered maritime Southeast Asia more than once, and some of those island histories continued long enough to produce forms of humanity unlike anything preserved on the mainland. Flores provides the clearest example. At Mata Menge, in the island's Soa Basin, hominin fossils dating to about 700,000 years ago include teeth, jaw fragments, and limb bones. They are older than the famous remains from Leang Bulu, but share features that link them to the ancestry of Homo floresiensis. The Mata Menge fossils demonstrate that the unusual anatomy of later Flores populations did not appear suddenly near the end of the Pleistocene. Some of its defining trends had begun hundreds of thousands of years earlier, behind a barrier of sea. A study published in 2024 sharpened that picture through a tiny adult upper arm bone from Mata Menge. The fragment indicates an individual of extremely small stature, possibly even smaller than the later Homo floresiensis specimens from Leang Bulu. Combined with the teeth and jaw remains, it suggests that major body size reduction occurred early in the island lineage. Descendants of larger-bodied ancestors may have reached Flores and, within several 100,000 years or less, evolved bodies adapted to the constraints of a small island. Island dwarfing is well known among other mammals. When large animals become isolated where food is limited, ranges are restricted, and predation pressures differ. Smaller bodies can become advantageous. They require fewer calories, mature under different schedules, and may survive periods of scarcity more effectively. Flores once supported dwarf proboscideans, while giant rats moved in the opposite direction and became larger. The island reshaped lineages according to local opportunity rather than any single universal rule. Hominins were not exempt from these evolutionary pressures. The Flores evidence has encouraged speculation that Sulawesi might also have produced an unknown island form. The possibility is legitimate, but the comparison must be controlled. Sulawesi is far larger than Flores, with greater ecological diversity, broader river systems, extensive mountain ranges, and more room for populations to move. Resource limitations would not have operated in the same way across the island. A hominin lineage isolated there might have become smaller, larger, more regionally varied, or changed little in body size. No fossil allows one outcome to be preferred. Nor does the similarity in occupation dates establish that Calio's makers were ancestors of the Flores lineage. They may have come from different source populations at different times. A dispersal from Sunda could have reached Flores through one chain of islands and Sulawesi through another. Rare rafting events could scatter related groups across Wallacea without continuous contact. Alternatively, several hominin lineages may already have occupied Southeast Asia and crossed independently. The archaeological record is too thin to arrange these movements into a single clean route. Technology offers little resolution. The early Flores assemblages like Calio contain simple cores and flakes. This resemblance may reflect shared ancestry, but it may also reflect the practical demands of obtaining sharp edges from local stone. Simple reduction methods are highly reusable and can be reinvented. On an island where a flake performs the required task, there is no evolutionary obligation to produce more elaborate forms. Scholars still debate how much technological similarity across Wallacea represents cultural connection and how much represents convergence. Flores nevertheless changes what can reasonably be imagined for Sulawesi. It proves that an island population could remain isolated for hundreds of thousands of years. It proves that a lineage could survive repeated climatic shifts, volcanic events and ecological change while developing distinctive anatomy. It also proves that the absence of complex-looking tools does not imply a brief or unsuccessful occupation. The later Homo floresiensis population maintained a modest stone technology while persisting within a remarkable evolutionary history. That lesson makes the silence at Calio deeper. If hominins reached Sulawesi at least 1.04 million years ago, they had time to undergo profound changes before the later evidence at Talepu. More than 800,000 years separate the two sites. That interval is long enough for species to transform, populations to divide, and lineages to disappear. Yet there is no Sulawesi equivalent of mata menge. No jaw records a change in diet. No limb bone reveals stature. No skull preserves brain size or facial form. The island offers time without anatomy. Sulawesi's greater size may also have supported more than one population. Mountain barriers, peninsulas, and deep gulfs could isolate groups within the island itself. A lineage arriving in the southwest might remain separated from another entering through the north. Local environments could produce regional differences. Later volcanic eruptions, sea level changes, and shifting habitats might reconnect or divide them again. This is inference rather than evidence, but the geography permits a more complicated evolutionary landscape than the single small island model often imagined for Flores. The comparison also warns against treating island evolution as a march towards strangeness. Homo floresiensis appears unusual because its fossils survive and can be measured against other humans. A Sulawesi lineage might have looked equally distinctive, or it might have retained an anatomy close to its mainland ancestors. Evolution does not seek novelty. It tracks survival and reproduction under local conditions, constrained by chance, population size, and inherited variation. Without bones, even the direction of change remains unknown. What survives in the record suggests only that Sulawesi offered enough resources for toolmakers to act within its interior after a marine crossing. Flores shows what could happen when such arrivals became enduring populations, bodies altered, lineages persisted, and isolation generated outcomes no mainland sequence predicted. But Flores is a comparison, not a template. The Calio makers cannot be turned into hobbits by proximity or imagination. Still, somewhere between the first landing and the last trace of an unknown lineage, evolution must have continued. Bodies aged, generations replaced one another, and inherited traits shifted whether the population survived for centuries or hundreds of millennia. Calio captures none of that change. It preserves the opening gesture, a few sharp flakes beside a river. Flores preserves enough fossils to reveal an island experiment. Sulawesi leaves the experiment sealed, reminding us that an evolutionary history can be immense, even when its participants remain completely invisible. The sealed experiment on Sulawesi becomes less isolated when Luzon is brought into the same frame. Far to the north, beyond deep water channels, Kalinga preserves evidence that hominins reached an oceanic island hundreds of thousands of years before Homo sapiens is known to have entered the region. The site does not identify the Calio toolmakers, nor reveal a migration route linking the islands. What it does show is that early crossings into Wallacea and neighbouring island zones were not confined to one place, one moment, or one lineage. By the Middle Pleistocene, unknown hominins had appeared on Luzon, processed a large animal, and left behind a stone technology adapted to local conditions. The Kalinga discovery centres on the partial skeleton of a rhinoceros dated to between about 777,000 and 631,000 years ago. Around it, archaeologists recovered 57 stone artifacts and hammerstones. Many of the rhinoceros bones carry cut marks and percussion damage consistent with dismemberment and the extraction of marrow. Unlike Calio, where the exact use of the flakes remains unknown, Kalinga preserves a direct relationship between tools and animal processing. Someone used sharp stone on a carcass, broke selected bones, and left enough traces for the sequence to be reconstructed much later. That clarity should not be transferred back to Sulawesi. The Calio artifacts have not been found beside cut-marked animal remains, and no evidence shows that their makers hunted or butchered the island's pigs or proboscideans. Kalinga provides a comparison in capability, not proof of identical behavior. It demonstrates that non-modern hominins in island Southeast Asia could organize around a large carcass and use stone tools effectively. Calio proves only that other hominins produced flakes beside an ancient river. The distinction matters because neighboring discoveries can easily become fused into a single imagined culture that the evidence does not support. Luzon, like Sulawesi, was never joined to the Asian mainland by a dry land bridge during Pleistocene low sea levels. Reaching it required at least one marine crossing. The precise route remains disputed. Hominins may have arrived through northern island chains, from northern source regions, or through another pathway no longer visible in modern geography. As with Sulawesi, accidental rafting, simple flotation, and deliberate movement all remain possible. No preserved vessel accompanies the Kalinga tools. The presence of rhinoceros remains also adds an ecological parallel. Large land mammals somehow crossed the sea barriers before or alongside hominins, reminding us that rare dispersal events shaped entire island faunas. The stone technology at Kalinga appears simple, but simplicity again conceals flexibility. The assemblage includes cores, flakes, and hammerstones produced through direct percussion. Raw materials were obtained locally, and the reduction strategies focused on creating workable edges rather than elaborate standardized forms. A detailed technological analysis published in 2026 further examined how knappers selected cobbles, exploited natural surfaces, and adjusted blows to the stone. The results add nuance to the picture of uniform early island technology. Even within broadly simple flake industries, choices varied from site to site and between reduction sequences. That diversity is important for comparing Kalinga with Calio, Talepu, and early Flores sites. Similar-looking flakes do not necessarily indicate direct cultural transmission. Hominins working river cobbles often face the same mechanical problems and may arrive at comparable solutions independently. Yet differences in platform choice, core rotation, hammer technique, and flake removal can reveal local habits. These habits may reflect learned traditions, raw material constraints, or immediate tasks. The record remains too sparse to trace a continuous technological family across the islands, but it is no longer accurate to treat every early assemblage as interchangeable. Kalinga also changes assumptions about what kinds of hominins could cross water. The site predates the known fossils of Homo luzonensis from Calio Cave by hundreds of thousands of years. Whether the Kalinga toolmakers were ancestors of that later species is unknown. They might belong to an earlier population that disappeared, a lineage that evolved locally, or a separate arrival altogether. The temporal gap is large, and no hominin bone was found beside the rhinoceros. As at Calio, behavior appears before anatomy. The later Calio fossils reveal a small-bodied human relative with a mosaic of traits, some appearing ancient and others more derived. Their discovery proves that Luzon eventually supported a distinctive hominin population. It does not allow researchers to project that anatomy backward to Kalinga. Still, the sequence raises a possibility familiar from Flores. Early isolation may have created long evolutionary histories behind marine barriers. Luzon may have received one founding population or several, with replacement, survival, and divergence unfolding across immense intervals. Sulawesi may have experienced an equally complicated history while preserving even less of it. The repeated pattern across the islands is therefore not a chain of known species marching eastward. It is a series of presences separated by water and by missing evidence. On Flores, early tools are followed by fossils. On Luzon, a butchered rhinoceros is followed much later by Homo luzonensis. On Sulawesi, Calio is followed after a vast gap by younger archaeological sites, but no ancient hominin body has yet emerged. Each island preserves a different part of the same broader problem. Arrival can be demonstrated long before identity can be established. These comparisons weaken the old assumption that open water dispersal required modern human cognition, advanced speech, or purpose-built boats. They do not prove that earlier hominins were navigators. Instead, they show that marine barriers were crossed repeatedly by populations using technologies that appear modest in stone. Some crossings may have been accidental, some may have involved basic craft and intention. Different islands may record different mechanisms. The recurrence itself is the challenge. A single unlikely drift can be dismissed as an evolutionary accident. Several island occupations across hundreds of thousands of years suggest that rare events, simple behaviors, or both were more effective than once believed. Kalinga also gives Calio a sharper scale. The Sulawesi artifacts are older by several 100,000 years at their minimum age, yet they preserve less information about subsistence. The Luzon site is younger, but its cut-marked rhinoceros exposes a moment of coordinated activity. Archaeological richness and antiquity do not advance together. One site may be older but silent about diet, another younger but vivid about carcass processing. The past survives unevenly, and every comparison must respect that unevenness. Across the seas between Sunda, Sulawesi, Flores, and Luzon, the map now fills with isolated points rather than a continuous route. Each point marks hominins where older models did not expect them. None supplies the complete journey. Kalinga confirms that Sulawesi was not the only island reached by premodern humans, but it does not make the crossing easier to explain. Instead, it multiplies the mystery. More than once, different shores received travellers whose boats, bodies, and origins disappeared, leaving stone behind as the only durable witness. The isolated points across Wallacea become most unsettling when the story returns to Sulawesi itself. Calio places hominins on the island at least 1.04 million years ago, but the next secure archaeological anchor lies far later at Talepu, where stone artifacts were dated to at least about 194,000 years ago. Between those two sites stretches more than 800,000 years, with almost no direct evidence of who lived on the island, how often populations arrived, or whether any lineage endured from the early Pleistocene into the much younger record. The gap is not merely an empty interval on a timeline. It is long enough for entire human populations to evolve, divide, disappear, and be replaced without leaving a known fossil. Talepu lies in the same broad Walani region of South Sulawesi, though it represents a different locality and a far younger stage of the basin's history. Excavations there recovered stone artifacts from sedimentary layers dated through a combination of techniques, including uranium series analysis and paleomagnetic evidence. When the findings were published in 2016, they established that hominins had reached Sulawesi long before the arrival of Homo sapiens documented elsewhere in the island's later archaeological record. At the time, an age of at least 194,000 years already forced researchers to confront a deep-water crossing by an unknown premodern population. Calio did not overturn that conclusion. It pushed the same problem backward by roughly another 850,000 years. The temptation is to draw a continuous line between the two sites. On a diagram, Calio can appear as the beginning and Talepu as a later station in one long occupation. The stone artifacts at both localities are broadly simple, and both occur within the Wallenai landscape. Yet archaeology cannot convert geographical proximity and technological resemblance into biological continuity. Simple flakes can be produced by different hominin groups separated by vast spans of time. River basins repeatedly attract populations because they provide water, stone, animals, and travel corridors. Two occupations in the same region may reflect inherited tradition, independent adaptation, or coincidence created by where sediments survived and researchers could excavate. More than 800,000 years is an almost unmanageable interval. For comparison, it exceeds the known duration of Homo sapiens by several times. Across such a span, climate cycles repeatedly lowered and raised sea levels, forests expanded and contracted, rivers shifted, volcanoes erupted, tectonic movement altered valleys, and coastlines moved tens of kilometers. Populations could flourish during favorable periods and vanish during droughts, eruptions, ecological disruption, or demographic decline. New groups could cross from elsewhere and occupy landscapes whose earlier inhabitants had disappeared so completely that no cultural memory remained. One possibility is long continuity. Descendants of the Calio population may have survived on Sulawesi for hundreds of thousands of years, adapting to changing environments while maintaining a flexible stone technology that left few distinctive markers. The island's size and ecological diversity could have supported refuges during climatic instability. Isolated groups might have moved between river valleys, interior basins, and coastal zones, leaving sparse open-air sites that tropical weather later destroyed. If this occurred, Talepu could represent a distant descendant of the earliest occupation, though no fossil or diagnostic technological sequence currently links the two. A second possibility is extinction followed by recolonization. The first population may have been small and vulnerable. A few failed generations, disease, resource collapse, or an environmental catastrophe could have ended the lineage. Hundreds of thousands of years later, another group might have crossed the sea independently. The water barrier was difficult, but, as Flores and Luzon show, not uncrossable. Repeated rare arrivals may explain the island record better than one continuous population, yet the evidence cannot reveal how many colonization attempts succeeded, how many failed, or whether some left no artifacts yet discovered. A third possibility combines both patterns. Sulawesi may have hosted several populations at different times, some persisting, others disappearing, and perhaps occasionally overlapping. Its peninsulas and mountain systems could isolate groups within the island. A northern arrival need not encounter a southern population immediately, if at all. Later movements could bring them into contact, competition, or exchange. But there is no direct evidence for any such meeting. The geography permits complexity. The archaeological record does not yet resolve it. The apparent emptiness between Calio and Talepu may also be a product of preservation and research, rather than true absence. Tropical open-air sites are difficult to preserve. Acidic soils dissolve bone. Heavy rainfall erodes surfaces and redeposits artifacts. Dense vegetation hides ancient terraces, while modern agriculture disturbs shallow layers. Sea level rise submerged coastal sites that might once have recorded repeated arrivals. Deeply buried deposits may remain beneath fields or river sediment, and caves containing older material may not yet have been located or excavated to sufficient depth. Talepu's artifacts also remain anonymous. No hominin fossil identifies their makers. They could represent descendants of an ancient island lineage, a later Homo erectus-related dispersal, or another population entirely. The tools alone cannot decide. Their age places them before the secure regional appearance of Homo sapiens. But chronological position does not supply a species name. As at Calio, behavior survives while anatomy is missing. Even the phrase still or again present carries the uncertainty. If Talepu represents continuity, Sulawesi may preserve one of the longest insular hominin histories known anywhere, hidden almost completely from view. If it represents recolonization, then the surrounding seas were crossed on more occasions than the sparse record reveals. Both interpretations are consequential, and neither can yet be preferred securely. More excavation in the Walanai Depression, especially in deposits between the known age ranges, could transform the problem. A single tooth, dated layer, or dense artifact horizon might connect the sequence or prove that it contains major breaks. The long silence, therefore, becomes evidence of a different kind, not proof of what happened, but a measure of how little survives. At one end, 7 flakes emerge from a river deposit more than 1 million years old. At the other, Talepu confirms hominins still or again present by about 194,000 years ago. Between them lies enough time for an entire hidden evolutionary history. Perhaps one lineage endured behind the sea barrier. Perhaps the island was abandoned and entered repeatedly. Perhaps several human forms came and went. For now, Sulawesi offers 2 firm points separated by an abyss of time, and every possible bridge between them remains unbuilt. The abyss between Calio and Talepu does not become much smaller at Leang Bulu Bettue, but it begins to acquire texture. This limestone cave in southwest Sulawesi preserves a deep archaeological sequence, nearly 8 meters of sediment laid down across an immense span of time. Unlike the exposed river deposits of the Walanai Depression, the cave offers a protected interior where repeated visits, discarded tools, animal remains, and changing behavior accumulated layer by layer. The sequence does not connect Calio directly to later humans, and it cannot identify the makers of the older artifacts. It does, however, reveal that Sulawesi's human history before Homo sapiens was more complex than a pair of isolated stone scatters. The deepest archaeological layers have been dated to roughly 400 to 132,300 years ago. The gap remains enormous, but Leang Bulu Bettue opens a new window into the later part of that silence. Within the older deposits, researchers found stone artifacts, animal remains, and traces suggesting that hominins repeatedly used the cave and its surrounding landscape. The site preserves a more substantial record of activity, although its duration remains uncertain. Even so, the stratified sequence is far richer than the isolated open-air traces that define the island's earlier record. Among the older artifacts are relatively simple cobblecore and flake technologies. Nappers selected stone, struck flakes from cores, and produced cutting edges without the highly standardized forms familiar from some later industries. The assemblage also includes heavy pointed implements often described as picks. These tools were made to create robust working ends, perhaps for digging, chopping, breaking, or processing resistant materials. Their exact function is not securely known. A pointed stone may have served more than one purpose, and use wear or residue evidence has not reduced the possibilities to a single task. What survives in the record suggests a practical technology adapted to local stone and immediate needs. Animal remains provide a stronger behavioral signal than at Calio. Some bones from the oldest sequence preserve evidence consistent with processing by hominins. The record does not justify turning every occupant into a specialized hunter or reconstructing dramatic confrontations with large animals. Carcasses could have been hunted, scavenged, or encountered through several strategies. Stone edges might have been used to remove tissue, open joints, or prepare other resources. The evidence confirms interaction with animal remains more clearly than the 7 Calio flakes do, but it does not reveal the full economy of the cave's inhabitants. The cave's position near rich karst landscapes would have offered access to water, stone, forest resources, and animals moving through nearby valleys. Sheltered interiors can provide temporary refuge from rain and heat, yet caves are rarely complete homes in the modern sense. Occupation may have been intermittent, seasonal, or task-specific. Groups could have used the entrance for short stays, processing food, repairing tools, or sheltering during movement through the region. Sediment accumulated slowly, compressing separate episodes into layers that appear continuous. Archaeologists must therefore distinguish repeated visits from uninterrupted residence. No hominin fossil securely identifies the makers of the oldest Leang Bulu Bettue industries. They may represent a late surviving archaic population related to earlier Sulawesi inhabitants, a new dispersal from elsewhere, or several populations using the cave at different times. The technology alone cannot assign a species. Its simplicity is compatible with many hominins and may reflect raw material, mobility, or function rather than limited ability. As at Calio and Talepu, stone preserves action more readily than identity. The sequence becomes especially important because a pronounced cultural shift appears around 40,000 years ago. Above the older deposits, the archaeological record changes. New forms of behavior become visible, including symbolic expression and artistic activity associated with Homo sapiens in Sulawesi. The island's later caves preserve some of the world's oldest known figurative art, hand stencils, pigments, ornaments, and other signs of social worlds communicated through images and objects. At Leang Bulu Bettue, the transition is not simply a gradual increase in the number of flakes. It marks a different archaeological signature, one suggesting new practices, new ways of using caves, and perhaps new people. Researchers have raised the possibility that this change reflects the arrival of Homo sapiens and the replacement of an older hominin population. That is plausible, but it is not a demonstrated event captured in a single layer. No skeleton from the older occupation lies beneath a modern human burial. No deposit preserves direct contact, conflict, interbreeding, or exchange between two identified groups. The shift could represent population replacement, cultural transformation within a changing population, separate phases divided by an occupational hiatus, or a mixture of processes. Scholars still debate how sharply the layers record biological change rather than changes in behavior and preservation. The timing also requires caution. Archaeological dates are ranges, and cave sediments can contain disturbances, erosion, and gaps. A younger cultural phase beginning around 40,000 years ago does not prove that archaic hominins survived until the exact moment modern humans appeared. The older inhabitants may have vanished long before, leaving the cave unused for a period. Conversely, they might have persisted elsewhere on Sulawesi after Homo sapiens entered another region. Without directly dated fossils from both populations, overlap remains possible but unconfirmed. This uncertainty gives the cave unusual importance. Leang Bulu Bettue may eventually help reveal whether Sulawesi witnessed a meeting between distinct human populations, but current evidence stops short of that conclusion. More excavation, refined dating, ancient proteins, or fossil discoveries could alter the picture. A tooth from the older layers might identify a lineage. A modern human remained securely tied to the later phase could anchor the transition. For now, the sequence records cultural difference more clearly than biological succession. The cave also warns against imagining Sulawesi's prehistory as one unbroken climb from simple flakes to art. Technology does not move inevitably toward complexity, and symbolic behavior may leave no trace in earlier open-air sites. Organic objects, body decoration, gesture, and oral tradition can disappear completely. The older inhabitants may have possessed social practices invisible to archaeology. At the same time, the later record genuinely expands in symbolic visibility. Pigment, images, ornaments, and transformed cave surfaces create a different relationship between people and place. Leang Bulu Bettue therefore stands between the anonymous stoneworkers of deep time and the image-making humans who later entered Sulawesi's caves. Its lower layers preserve practical tools and processed animals. Its younger sequence belongs to a world where marks could carry memory and meaning beyond immediate survival. The transition may conceal replacement, encounter, or absence. No single explanation fully accounts for it, yet the sediments do not show one people stepping aside as another enters. They show a long cave history divided by a profound change. While the identities on either side remain unequal, one population visible only through stone, the other approaching the threshold of art. At the threshold of art, Sulawesi's story changes again. On the island of Muna, southeast of Sulawesi's central body, a limestone cave called Liang Metanduno preserves a hand stencil made by a later human presence. The image is simple, a hand placed against rock while pigment was blown or sprayed around it, leaving the pale shape of fingers and palm within a field of colour. Yet the date attached to that gesture is extraordinary. Research published in January 2026 established a minimum age of 67,800 years for the stencil, making it one of the oldest dated examples of rock art known anywhere. Nearly 1 million years separates this image from the stone flakes at Calio. Between them lies most of the human history of Sulawesi, missing, eroded, submerged, or still waiting inside caves and ancient sediments. The hand stencil belongs to Homo sapiens, not to the unidentified hominins who made the Calio artifacts. That distinction must remain firm. Nothing about the image reveals the identity of the island's earliest toolmakers, and nothing at Calio demonstrates symbolic art. The two discoveries are connected by place and by the depth of time, not by proven ancestry. The person whose hand touched the cave wall may have descended from populations arriving in Wallacea tens of thousands of years earlier, but not from the early Pleistocene group in any line that archaeology can presently trace. The gap is too large, the fossils are absent, and the history of replacement and migration remains unresolved. Even so, the contrast is powerful. At Calio, a controlled blow survives as a sharp edge detached from stone. At Leang Bulu, the outline of a hand survives because pigment settled around skin. One record preserves an action through fracture, the other preserves absence, the space once occupied by flesh. Neither gives us a face, neither gives us a name, yet the later image feels intimate in a way the flakes do not, because its scale matches the viewer's own body. The fingers spread against the limestone as fingers still can. The gesture crosses time without requiring translation. Dating such an image is difficult because mineral pigment itself may contain no material suitable for direct radiocarbon analysis, and an age beyond 50,000 years approaches or exceeds the practical limits of that method. Researchers instead examined mineral crusts that formed in relation to the stencil. Uranium series dating can measure the decay of uranium isotopes within thin calcium carbonate deposits laid down by water moving across the cave wall. If a mineral layer formed above pigment, its age provides a minimum the image beneath must already have existed. The reported date of at least 67 to 800 years therefore does not necessarily mark the exact moment the hand was placed there. The stencil may be older. This minimum age extends Sulawesi's record of image-making deeper than previously confirmed and strengthens the island's position within the earliest known history of figurative and symbolic art. Other caves in the region preserve painted animals, narrative scenes, and hand stencils dated to later periods. Together, they show that Homo sapiens communities in Wallacea were not merely passing through towards Sahul. They occupied landscapes, returned to caves, shared symbols, and altered rock surfaces in ways that endured. Their maritime world was culturally rich long before the better-known painted caves of later Europe reached their celebrated forms. Yet the hand should not be used to solve the earlier crossing by analogy. Homo sapiens arriving in Wallacea possessed a different evolutionary history, broader social networks, and behaviors documented through ornaments, pigments, and complex technologies. Their ability to cross seas does not explain how an unknown hominin reached Sulawesi more than 1 million years earlier. The two maritime episodes may have involved entirely different routes and means. The later travellers may have used planned watercraft, while the first arrivals could have drifted accidentally from Borneo, or early hominins may have possessed simple flotation skills whose organic traces vanished. The record establishes repeated crossings, not one continuous maritime tradition. The long sequence now visible on Sulawesi is therefore composed of disconnected thresholds. Calio marks the earliest known arrival, at least 1.04 million years ago, and possibly as old as 1.48 million years. Talepu shows hominins present again, or still present, by about 194,000 years ago. Leang Bulu Bettue preserves older cave occupations and a later cultural transformation. Leang Bulu carry a Homo sapiens hand stencil at least 67 to 800 years old. Each point is secure enough to reshape the story, but the lines between them remain conjectural. What happened to the Calio population is unknown. If its members established a lasting community, their descendants may have evolved in isolation for hundreds of thousands of years. If they failed, Sulawesi may have returned to silence until another crossing. Several lineages may have entered and disappeared, leaving similar flakes that cannot distinguish them. Later archaic populations may have met incoming Homo sapiens, avoided them, mixed with them, or vanished long before they arrived. No fossil sequence presently chooses among these possibilities. The disappearance may also be partly an illusion produced by preservation. Bodies decay, tropical soils dissolve bone, shorelines drown, rivers cut through their older beds, while caves seal deposits beneath meters of sediment, A lineage can occupy an island for thousands of generations and still leave only a handful of objects where archaeologists happen to look. Calio itself demonstrates this imbalance. 7 artifacts transformed an island timeline by more than 800,000 years. Another trench, another tooth, or another cave could transform it again. For now, the title's final uncertainty remains justified. The deep water crossing happened, but we still cannot explain its route, its vehicle, its degree of intention, or the species that completed it. The modelled path from Borneo shows that a 3 to 8 day drift was possible under some conditions. Geography confirms that low sea level narrowed the distance without removing the sea. Stone technology proves that toolmakers were alive on Sulawesi after the journey. Everything between the departing shore and the first strike at Calio remains outside the evidence. The hand at Leang Bulu does not close that gap. It illuminates the far side of it. By the time Homo sapiens pressed skin to limestone, Sulawesi had already held human histories for nearly 1 million years. Some belong to populations with no surviving name. Some may have ended without descendants. The cave artist could not have known that far beneath another part of the island. Ancient river sandstone contained the work of hands from an incomprehensibly older world. Yet both traces now belong to the same unfinished record: a flake where stone was removed, and a stencil where a hand was removed, each preserving the shape of an action after its maker vanished. And so the story settles back into the island itself. The rivers continue toward the sea. Rain passes over the limestone hills, entering cracks, leaving thin mineral skins upon painted walls. Far below cultivated ground, sandstone still holds fragments that no living memory carried forward. The Makassar Strait remains open to the west, darkening under weather, its depth unchanged by the questions placed upon it. There's no need to imagine a heroic fleet moving across that water. Perhaps there was only a storm, a broken riverbank, and several figures clinging to roots as the coast faded. Perhaps there was a simple float pushed toward a distant cloud above unseen mountains. Perhaps the crossing happened more than once, in different centuries, through different combinations of intention and chance. The sea keeps those versions equally quiet. No monument marks their landing, and no inherited story remembers their passage. Only the island's enduring separation tells us that some impossible distance was crossed long ago. What remains is smaller than the journey: 7 pieces of stone, a fossil tooth, reversed magnetism held inside sediment, later flakes in younger earth, animal bones in a cave, pigment around an outstretched hand. Human history often survives in this reduced form, not as a complete account, but as material that endured when memory could not. The first toolmakers of Sulawesi may have watched evening gather above a river whose course has vanished. They may have carried no idea that they had crossed a boundary future scholars would call Wallace's line. They simply found water, stone, food, shelter, and another day on an island beyond their former shore. Then generations passed, whether few or countless, and their story became geology. Much later, another hand touched cool limestone. Pigment moved through the air and settled around the fingers. The hand lifted away, leaving an empty shape that lasted longer than any spoken name. Between that stencil and the Calio flakes lies a silence almost 1 million years wide. The silence is not empty. It is filled with journeys, seasons, losses, births, discoveries, and disappearances that can no longer be recovered. Sulawesi keeps only their edges, and as night settles over its mountains and deep surrounding seas, those edges remain stone beneath the field, a hand upon the wall, and beyond them the faint enduring image of travellers crossing dark water toward a shore they could not yet call home.